Mr. Right here, how to solve simultaneous equations when one is linear and one is quadratic. Let's start with what you already know. You already know how to solve two equations simultaneously if they're both linear. Here's an example. Here are two linear equations, and you can see that they're linear because there is no x squared or x cubed term, and also when I plot the lines, as I've done on the right-hand side, they're both straight. Now, looking at the graph on the right-hand side, you can see that if I solve these equations simultaneously, there's going to be just one solution because the lines only cross in one place. And that solution is going to be x equals 3 and y equals 4 because they cross at the point 3, 4. Now, you need to know how to solve these equations algebraically as well, and you probably already do. But let's just remember the method because you'll need it in a moment. So, if I'm solving these two equations algebraically, I've got y equals something and y equals something else. So I'm going to say to myself, y equals this and y equals that. So therefore, this must be equal to that. Of course, the green and purple expressions must be equal to each other because they both equal y. So if this is going to equal that, then 10 minus 2x is going to equal 3x minus 5. And now I've got an equation which just has x's in it that I can solve in the usual way. I'm going to start by adding 2x to both sides. And now I'm going to add 5 to both sides. So now I've got 5x equals 15. Turn it around and divide both sides by 5. So x is 3. How am I going to find y? Well, the answer is you can substitute that value for x into either of your two equations. I'm going to substitute it in the top one. Y equals 10 minus 2x. So y will be 10 minus 2 3s is 6. So y will be 4. You could check that solution in the second equation, of course. And so the answer is x equals 3 and y equals 4. There you are. The algebraic answer agrees with the graphical one. So what about if you had one linear equation and one quadratic equation, such as y equals x plus 6, that's the linear one, and y equals x squared, that's the quadratic one. Now I've plotted both of these lines on the right-hand side here. The green is y equals x plus 6, and the blue is y equals x squared. And you can see that because the blue quadratic expression gives me a curve, I've got two crossing points. So there are 2 points which lie on both of the lines. There are 2 points which satisfy both the equations. So I'm going to get two answers when I solve these equations simultaneously. And I'm going to do that algebraically now. I'm going to follow exactly the same system as before, because I've got y equals this and y equals that. So in that case, this, which is x plus 6, is going to equal that, x squared. Now this is a quadratic equation, so I'm going to set everything equal to 0 and then factorize. I'm going to keep my x squared here positive. I'm going to minus x from both sides and minus 6 from both sides. And now I'll turn it around so that it's a bit easier to look at. So I've set my quadratic equation equal to 0, and now I'm going to factorize the left-hand side. Okay, I'm going to have x and x. They multiply to a negative, and they add to minus 1. There we go. And so the solutions to that quadratic equation are that x equals 3 or x equals minus 2. Now, each of those values for x is going to give me a different answer for y. How am I going to find that answer for y? Well, I'm simply going to use one of the equations that I've got up here. I'll use the first one, y equals x plus 6. So if y equals x plus 6, when x is 3, y will be 3 plus 6, so y will be 9. And if y equals x plus 6, then when x is minus 2, y will be minus 2 plus 6, y will be 4. So my 2 points where the lines cross are where x equals 3 and y equals 9, or the point 3, 9, and where x equals minus 2 and y equals 4, or the point minus 2, 4. Let's just check that that's where my graphs, my two lines do cross. I said minus 2, 4. There's that point there. And the second solution was 3, 9. And there's the point, 3, 9. So there you go. We have solved the two equations simultaneously. Right, here's one for you to try. Okay, there you go. There's a little graph for you as well, so you can see that we're expecting two solutions when we solve these equations simultaneously. Why not pause the film and have a go? Okay, right, now I'm going to solve these equations simultaneously, see if you did it like me. So y equals this, and y equals that. Set this equal to 0, x squared minus 2x minus 3 equals 0, and factorize the left-hand side. X and x is going to be a minus and a plus, multiply to 3, so 1 and 3. I'm going to have minus 3 and plus 1 to give me minus 2x's. So what are my two solutions here? Well, one solution is that x equals 3, and another solution is that x equals minus 1. Okay, well, I'll use y equals 2x plus 3. Now, the first equation, because if x equals 3, then I can work out that y is 6 plus 3, 9. So that gives me the solution x equals 3, y equals 9. Or if x equals minus 1 and y equals 2x plus 3, then y will be minus 2 plus 3. So y will be 1, giving me the second solution, x equals minus 1 and y equals 1. Okay, one more to try yourselves. Here we go. Have a go at this one. Again, I've drawn the graph for you, so you can see that we're expecting two solutions. So perhaps pause the film and have a go. Okay, I'm going to do this one now. Y equals this, and y equals that. That's a quadratic. Set it equal to 0. It's going to be a little more difficult to factorize this one. I'm going to have 2x and x. Okay, now I'm looking for numbers that multiply to 6. So probably 2 and 3, or it could be 1 and 6, of course. Now, one of them has got to be negative, and one of them's got to be positive. That's not going to be right, because that's not 3 and 2. Let's try that. Right, just check that. If I multiply that out, I get minus 3x's and plus 4x's. That would give me plus an x, so that's no good. So I'll change the signs, make that a plus 3, and make that a minus 2. Now, if I multiply that out, I get plus 3x's minus 4x's, which would give me minus 1x. So that's the expression factorized. So now I need to find my values for x. Well, to make the first bracket equal to 0, x is going to have to be minus 1.5. And to make the second bracket equal to 0, x has to be 2. And now for each of those, I can find my value for y, because I know that y equals x plus 6. So if x is 1.5, then y will be 1.5 plus 6. Sorry, if x is minus 1.5, then y will be minus 1.5 plus 6, which is 4.5. That gives me the solution x equals minus 1.5 and y equals 4.5. And if x is 2, then y equals x plus 6, which is going to be 2 plus 6, which is 8. So that gives me the solution x equals 2 and y equals 8. Let's check that that looks right. On my graph, you can see that this point of intersection on the left is minus 1.5, 4.5, and the point of intersection on the right, this one here, is 2, 8. So that is how to solve simultaneous equations when one of them is linear and one of them is quadratic. You'll find more to practice later on in this playlist. So I hope you found the film useful. If you did, please tell me by hitting like, and that helps other people see the film and helps the channel too. If you've got a question or you'd like some more help, please do leave me a comment and I'll respond, or leave me a comment anyway. And lastly, if you haven't already, please consider subscribing to this channel for everything you need to ace your IGCSE Maths.